How does the call stack make recursion possible? Imagine trying to solve a puzzle where each piece depends on the one before it. How does the computer keep track of all those pieces? That's where the call stack comes in. It's like a to-do list that the computer uses to remember what it was doing before calling a new function. When a function calls itself, it's called recursion. For this to work smoothly, the computer needs a way to keep track of each call. The call stack creates a new box or frame for each function call. This frame holds important details like the function's inputs, local variables, and where to go back after the function finishes. Every time the function calls itself, a new frame is added on top of the stack. Think of stacking plates one after another. The current function pauses, waiting for the inner call to finish. This stacking allows multiple versions of the same function to run at once, each with its own set of data. Recursion stops when a base case is reached. This is a condition that tells the function to stop calling itself. When that happens, the function starts returning, and the call stack begins to unwind. The frames are removed one by one, and each paused function resumes where it left off. This process is what makes recursion possible. The call stack manages the flow of control, making sure each function call has its own space and that the program knows where to go back after each call. Without the call stack, the computer wouldn't remember what to do next, and recursion wouldn't work. From a debugging point of view, understanding the call stack is super helpful. It shows you the chain of function calls leading to a problem. If your recursive function isn't stopping, the call stack will show you how many calls are still active and what the current data is. This helps you find issues like missing base cases or infinite loops. When you're debugging, each recursive call pushes a new frame onto the call stack. As calls finish, frames pop off, shrinking the stack. If the stack gets too big, it can cause a stack overflow error, which means your recursion went too deep. That's why having a good base case is so important. Using the call stack to understand recursion helps you write better code and fix bugs faster. It's like having a map that shows you exactly what's happening inside your program at each step. Mastering this concept makes debugging recursive functions much easier and keeps your programs running smoothly.